Hello everyone. Today our topic is adding long integers using linked list. So in this presentation we will be exploring a program to add two long integers using linked list, a fundamental data structure in computer science. We the team of four, Disha BV, Jeevita M, Dhanush Kumar NS and Darshan S have successfully implemented the code and we have got the correct output. So without any further delay, let us start learning what actually it is. As we all know, a linked list is used to represent long integers because it allows for efficient storage and manipulation of very large numbers without the limitation of fixed size data types, enabling easy addition and subtraction of digits. So, if you ask us why linked lists for long integers, so it basically provides integer overflow, dynamic memory allocation, and performing arithmetic operation on long integers. So because it also allows us to represent large numbers without any fixed size limitations, and traditional integer data types have some limitations. So there we can only represent number within a fixed range, that is called integer overflow, and we have explained here dynamic memory allocation. Let's move further. So now representing long integers as linked lists. So the each digit of the long integer is stored in separate node of the linked list. The node are linked together in a order, starting with least significant digit. So now here least significant digit is which is the rightmost digit in the number, that is which represents the smallest place value in the number. It can also be the lowest exponent value. Reversing the linked list. So before adding the linked list, first we must keep in mind we must reverse them, because it ensures that the digits are added from the least significant to the most significant. So the most significant digit, it is the leftmost non-zero digit, that is which has the highest place value in the number and which is usually the first digit when reading from the left to right. So that is called most significant digit. Now adding digits from least significant to the most significant. So what does this mean? So basically it is to take a number and sum of its digit and starting from the rightmost, that is the smallest place value digit, and moving leftward to the leftmost, that is the largest place value digit. Like, adding the digits one by one in order from the ones place to the tens place, hundred place, and so on. Now if you want, you can imagine some random number. So let me say like 123. So here the least significant digit is 3, that is in the ones place. So the next digit is 2, that is the tens place. So the most significant digit is 1, that is in the hundreds place. Now you add all 3 plus 2 plus 1. So the sum of all the digits is 6, that way. Handling carryover during addition. So we reverse both original linked list to start from the least significant digit. We can use pointers to transfer the reverse trace simultaneously. So if the two sum of the digits exceeds 9, so we basically carry over the extra value to the next digit position. This is very crucial because to ensure the accurate results. So now 5 plus 5, that is 10. So it is exceeding the 9. So we carry the extra value to the next digit position. So handling unequal length linked list. So what it is? So typically a user, like, we need to iterate through each linked list independently, like checking for the end of the shorter list at the each step and performing the desired operation, like only until that point is reached we need to keep performing the desired operation. It actually involves a loop that it keeps continuing as long as the pointers are not null, ensuring that you actually don't have to access the elements beyond the length of the shorter list. So you should keep the key points to remember when you're handling the unequal length. Okay, that is the you need to check for the null pointers, and you need to iterate until the shorter link ends, and you have to handle the edge cases also. So these are the key points you have to keep in mind while handling the unequal length linked list. Now displaying the final sum as linked list. So once the sum is calculated, you need to reverse the program resulting the linked list to present the final sum in the correct order, like from the most significant to the least significant. So basically the user needs to iterate through the original list, and we need to calculate the sum, and we need to create a new linked list where each node represent a digit of the calculated sum, and next we need to add nodes in the reverse order to handle the potential carrier when the summing large numbers. So these are the steps to display the final sum as a linked list. So this is the implementation code. So let me explain it part by part how actually it works. As you can see, we have used the three header files. The first one, stdio.h, it stands for the standard input output header file. The next one is the stdlib.h, that is the standard library function. And next one is the string.h, that is it used for the to represent the long integers or digits. Struct node is also called structural node, where it includes the function of intdigit, where int is a data type which includes a digit, and struct node is address to the next node. Struct node into malloc size of struct node. So this function includes the creation of a new node, which is used for the memory allocation of inserted digits. When new node is included digit and the next node includes the null character. Here the initializing address is assigned as null. The struct node is placed as a temporary node which is equal to the head, while the temp next is not equal to the null. But the temp next should be equal to the temp. So here in the next function we are initializing temp next to the new node, again written back to the initial position. So and come to the next function, we see the struct node address with reverse list, where it includes struct nodes with the address of initial position. Here we are initializing the struct node with the address of the previous node, where it is initialized to the null. And now the current node is initialized to head, and the next node is also initialized to the null, while the current node is not equal to the null. Now we are initializing the next node as the current node, and the next node as the previous node, the previous node as the current node. After the given input satisfy the condition, we again return to the previous node. Here at starting we are including carry as 0, while L1 and L2 are the two inputs, where at the starting the resultant node is addressed as null, while L1 and L2 are here, they are not equal to null. So and the carry, it should actually be included, and we are initializing sum, and it should be equal to the carry. If the L1 is not equal to null, we have to initialize the sum as L1 plus the previous sum. And now if you compare the current L1 with the previous L1, and if L2 is not equal to the null, so we are actually including sum as sum plus L2, and similarly comparing L2 with the current L2, just like the L1 as I said before. So now coming to the next thing, we are finding carry is equal to the total divided by 10, and the result should be equal to the sum mod of 10. Now we initialize head with the null, where it gives output as 0. Again we are including extra function, as you can see, where the temporary node is equal to the head, while temp should not be equal to null. We are actually printing out the temp value, and the temp should be initialized with the next temp. So now we are including int main function, where char is a data type which includes two inputs as num1 and num2 with the size of 100. Here we are including the first long integers as printf, and the percentage s as the input of the long character with num1, and similarly second long integer as num2. So coming to the next, struct node with the address of L1 is initialized to null, as you can see there, and struct node the address of L2 is also initialized to null. Here we are including a for loop, where for I here refers to string length of num1 minus 1, and I is post decrementing. Here I is basically post decrementing, and L1 should be equal to the append node, where num1 of I minus 0 is included. Similarly, it is the same way for num2. Now the resultant struct node includes the add list for of L1 and L2. The result should be the reverse list result, and the print, and it should print the result. After the execution, the L1 and L2 and the result should be free. Thank you, everyone. So, we hope our concept which we tried to convey you is crystal clear for you now.